So this is the part where I explain the code. This is a simple code that I've used for the example that I've showed in my short. I'll link the short down so you all can see how it works. Anyways, let's start. So here I'm just defining the pin of the sensor. I've connected the sensor on pin 11. Here I'm defining the LED pin, the pin where the LED is connected. Then we have our void setup block wherein I have defined, like I have set up the pin mode for the PIR sensor to be input as I am taking input from the sensor, and for the LED pin to be output as I'll be giving output to the LED, right? So I need to use that pin for giving output purposes. Right here I've just defined so that it is, I have that ease of writing LED pin and PIR sensor wherever I need to use the pin, so that if I change the pin I just have to change the value here rather than finding all 9s and all 11s and changing them. So, and it's better readability as well. So here I'm beginning the serial monitor. Now is the void loop block. In this I've just taken an integer called sensor value in which I am reading the data from the PIR sensor, right? And here I'm just printing the data from the PIR sensor. Now here this is a if else block. If the sensor value equal to 1, that is, if the sensor is giving output as 1, it means that some obstacle is there, or it has detected some movement, some changes. So it will send the input as 1, right? And if sensor value is 1, then it will this line will turn on the LED. It will set the LED pin high, which will turn on the LED if motion is detected. And if sensor value is to 0, that is no motion is detected, then the LED pin will be set to low and no power will be sent to it, thus the LED will be off. So yeah, basically this, due to this system, if it returns 1, that is motion is detected, your LED will be high, and if there is no motion, your LED will be low. So that was just the explanation of this basic code. Yeah, thank you. Infrared radiation exists in the electromagnetic spectrum at a wavelength that is longer than visible light. It cannot be seen, but it can be detected. Objects that generate heat also generate infrared radiation, and those objects include animals in the human body whose radiation is strongest at a wavelength of 9.4 micrometers. Infrared is in this range will not pass through many types of materials that pass visible light, such as ordinary window glass and plastic. However, it will pass through with some attenuation. Materials that is opaque to visible light, such as germanium and silicon. An unprocessed silicon wafer makes a good IR window in a weatherproof enclosure for outdoor use. It also provides additional filtering for light in the visible range. 9.4 micrometers infrared will also pass through polyethylene, which is used to make Fresnel lens to focus the infrared onto other sensor elements. The PIR sensor itself has 2 slots in it. Each slot is made up of a special material that is sensitive to IR. The lens used here is not really doing much, and so we can see that the 2 slots can see out past some distance, basically the sensitivity of the sensor. When the sensor is idle, both slots detect the same amount of IR, the ambient amount radiated from the rooms or walls or outdoors. When a warm body like a human or animal passes by, it first intercepts one half of the PIR sensor, which causes a positive differential, which activates the first element and then the other element, whereas other sources will affect both elements simultaneously and can be cancelled. When the warm body leaves the sensing area, the reverse happens, whereby the sensor generates a negative differential change. These pulses are what is detected. These change pulses are what is detected. The IR sensor itself is housed in a hermetically sealed metal can to improve noise, temperature, or humidity immunity. There is a window made of IR transmissive material, which is typically coated silicon, since it is very easy to come by, that protects the sensitive element. Behind the window are 2 balanced sensors. This image shows the internal schematic. There is actually a JFET inside, which is a type of transistor which is very low noise and buffers the extremely high impedance of the sensors into something a low cost chip like the B1S0001 can sense. Fresnel lens is a plano convex lens that has been collapsed on itself to form a flat lens that retains its optical characteristic, but it's much smaller in thickness and therefore has less absorption losses. On the back side, there are a bunch of electric components that process the data from the IR module.